Math 3, Unit 5, Section G. Today we're going to talk about graphing rational functions. Okay, and so we already spent a little bit of time here on Desmos.com, and so if you are just watching this, I would go to Desmos.com and plug in some of these equations to see what happens when you put different numbers inside. So help me out here though, when we have plus C here at the end, where does this shift? Good. So it's going to go up, the C value. Okay, and then when we have minus C, it will go down. Good. And then what happens when we have it in here?
Left.
Good. Left our C value, and then when you have a minus X, it'll go right C. And so we talked about what happens when we have a negative in front of our f of x, and it reflects about the x-axis. Unless, of course, our asymptote shifts, and we'll talk about that in a minute, it'll end up reflecting across that asymptote. Okay, and then where is it going to reflect if you have a negative inside like that? Very good, the y-axis. Okay, so on this equation, this is what our graph looks like. You can plug in values like for x and figure out what y is. So for instance, if I were to plug in 2 for x, y equals a half, right? And so you have like an ordered pair there that would be 2 comma a half. And so if you go right 2, see how it goes up about a half. And so you could make like a t-chart for these if you were wanting to find exact points where points are when you're graphing. You can just plug in values and solve to get ordered pairs. Now, there is a horizontal asymptote, and most of the time I'm going to abbreviate that as HA, standing for horizontal asymptote. And asymptotes are basically lines, so you want to make sure that you write that as an equation. And normally when we draw these, we draw them as dotted lines. And so you can't see it when you're graphing it in Desmos.com, but because of how the graph is and how it curves, you know that there's asymptotes at both x equals 0 and y equals 0. And so at those points, it's no solution. Like the graphs will not ever touch 0. Okay, are you with me there? Okay, and then our vertical asymptotes, will end up abbreviating those with VA. And so in this case, my horizontal asymptote is already written there. It's y equals 0. This one is x equals 0. Okay, so we're going to move on to this next equation and start working through it. Okay, the first thing is we should draw our asymptotes. Okay, and so we know that they start at 0, 0, and then this is basically telling us our shifts of our asymptotes. And so for my horizontal asymptote, which way will it shift? Which way will the y go? Okay, so here, let's go here. This x minus 2 right here, that's going to go with your x-axis. So if we're looking at our x-axis, remember we're going to do the opposite. And so if this says minus 2, we're actually going to go right 2. So my vertical asymptote, and we're going to draw that as a dotted line, is at x equals 2. In fact, if you go to F here on this problem, it says, are there any vertical asymptotes? And that would be, so I'm going to write VA, and that is x equals 2. So whatever's with the x, think about it as like being in parentheses and that you would set it equal to 0, and you end up finding that x equals a positive 2. Okay, and then we have the plus 1 there at the end, and that's dealing with the shifting of your y, your up and down. And so on that one, there's no x or anything with it, and so it's true to what it says. And so we're actually going to shift it up 1. And so this is my horizontal asymptote at y equals 1. So I'm going to go here to G and put HA, and that is y equals 1. Now, before I kind of graph anything, finding your y-intercepts and x-intercepts will be helpful in helping you with your graphs okay? How do I find a y-intercept? Do you guys remember what we do to find y-intercepts?
So x equal to 0.
Very good. So this really is a y, correct? And so we go y equals 1 over 0 minus 2 plus 1. And then we're just going to solve that. So that is really y equals negative 1/2 plus 1, which is really y equals what? What's a negative 1/2 plus 1? Positive 1/2, sorry. Right? 1 minus a half. Are we good with that being a half? Okay. So as an ordered pair, this is 0, 1/2, because we plugged in 0 for x and solved for y. So 0, a half, there's a point right here. Okay, so now we want to find the x-intercept. So how do I find my x-intercept? Good. So we plug 0 in for y, and we're going to solve for x. Now this goes back to kind of what we've been doing this whole unit, in that we want to get rid of, so we want to pay attention to extraneous solutions. So my extraneous solution would be what?
X cannot equal positive 2.
Good, x can't equal positive 2. And then also our LCD to get rid of our fractions. And my LCD on this problem would be what?
X minus 2.
So I'm going to multiply every single term by x minus 2. Now 0 times anything is what? 0. So 0 equals, here the x minus 2's cancel and I have 1. And then here 1 times x is x, and 1 times negative 2 is negative 2. So at this point I would combine like terms. And so we have 0 equals, and 1 and negative 2 makes negative 1 plus x. And then in order to get x by itself, I would add the 1 to both sides. And so 1 plus 0 is 1, so that means 1 equals x. And so my ordered pair for this would be 1 comma 0. And that is my x-intercept. So we go right 1, up 0, make our point. And so right there, remember, we know that it's getting very close to the asymptote. And so this curve goes like this, and the other one just curves like that. Again, I want us to pay attention to how our graphs right now are in quadrants 1 and 3. And in case you don't know, I'm just going to write it right here. Quadrants go 1, 2, 3, 4, just like that. Okay, domain. What does domain mean? All your x values. So looking at this graph going from left to right, what x values are there? Negative infinity, pretty much all the way to positive infinity, but there's one value that doesn't work. 0. So there are two ways you can write this. We can write it in interval notation, or we can also write it like this. So one way is saying that it's going to be all reals except x cannot equal 0. So you could write your domain like that. The other way would be to go parenthesis negative infinity to 0, and then the union with 0 to positive infinity. And notice that 0, how it's parentheses, which means that it can't equal that value. So either of these works. It's kind of up to you and how you write it. I, for some reason, have just been writing it this way because I feel like this way is shorter and easier. But again, it's up to you, whichever makes the most sense. So what do you notice? What will be the range? Range are your y values. So looking at this graph, going from, from up to down or down to up, what y values are included? Yeah, it's the same thing except for where does it not equal? Oh, I put 0. It's not 0. Oh, you guys didn't catch it. Except for what? 2. I'm thinking about our last graph. So this would be 2 here. sorry. Does that make more sense now? That it's not equaling at the value 2 here?
Oh, that
Because
makes
of our
sense. I was
shifting.
gonna say, where did you get the 0?
Yeah, I don't know. I'm not quite awake yet. Okay. So this is actually 2 in both of these spots. Okay, so let's go to the y again. And so what's the only value that is not included for y? Positive 1. So we're going to say all reals except y cannot equal what? 1. Now, if you wanted to write that in interval notation, that would be negative infinity to 1, and then the union of 1 to positive infinity. Okay? And you don't have to write both. You just need to write one of them. Okay? All right. When you are reading graphs, we're moving down to H. When you read graphs, you read them from left to right. So if I'm starting at the left from negative infinity, what is happening to my graph? Is it increasing or decreasing? Decreasing. Okay, and then you get to your asymptote, and I still am reading it from left to right, but then I start here, and then what's still happening? It's still decreasing. And so it says state the intervals on which the graph of f is increasing. Is it ever increasing? No. So you can write no solution, you can write none, whatever you want to do is fine, but basically this entire graph is decreasing. Okay, and then the last one, I, it says state the intervals. Now when they say intervals, they're wanting us to use interval notation. And interval notation is when we're using our parentheses and our brackets, okay? So it says where f is greater than 0. Okay, so on this graph, where do you see f is bigger than 0? And remember, we always start from left to right. So do you see how right here, this is above 0? So that means this is what? What value is that? Negative infinity. Very good. So negative infinity all the way to what value here?
Almost 1.
It's to 1. And we're going to go 1 with a parenthesis because at 1 is when it changes from being greater than 0 to being less than 0, right? And then we're going to go ahead and do our union. And then do you see over here how this is all above the x-axis? So that means it's all greater than 0. And so this starts at 2, right? But it doesn't equal 2, so that's why I'm going to use a parenthesis. And so we'd go 2 to positive infinity. Okay, any questions on this?
So for that last one, just for the x's on the left.
Yes, when you're talking about answers, you know, to an equation, and if they're saying greater than 0, they're talking about above the x-axis and below the x-axis. Okay? Any other questions on that? All right. So moving on to our next graph. Few things we should notice here. And that is that not only is there shifting up and down and right and left, this negative right here means you have a reflection. Okay? And if you want to, even if your computers are there and you want to type this equation into your Desmos.com to kind of see what this graph actually looks like and make sure that you're going to end up graphing it correctly, you can. But your asymptotes are, there's no like flipping or anything with asymptotes, okay? So the first thing would be, where is my x asymptote going to be? -1 is correct. Because remember, like with whatever is being added or subtracted, we would set that equal to 0, which ends up making a -1. So there is an asymptote here that we're going to go ahead and mark at -1. Okay, and my other asymptote for my y-axis is going to be at what?
-2.
Very good. And so once you plot these on here, if you want to go and look for where does it say vertical and horizontal asymptotes, you can, so we can go ahead and get those answers. And so vertical is up and down, so vertical asymptote, that right there is at x equals -1, because it's going through the x value of -1. Okay, G is my horizontal asymptote, and we're going to write that as,
Y equals -2.
good. Okay. So now from there, y-intercepts and x-intercepts. I'm going to give you guys just 1 minute, and I'd like you to plug in 0 for x, solve for y, get your y-intercept, and plot it on here. Okay, and then the same thing with your x-intercepts. You'll plug in 0 for y, and then solve for x, and get your x-intercepts.
Perpendicular means it makes 90 degrees angles. They didn't say anything here that told you what it really meant. Okay, also this angle right here, B to C to B to C to B, and this B to A to B. Again, we don't know that. The only thing they told us is that it's a median, and when it's a median, it's cutting just a line like that. Yeah.
Okay, so did you guys finish that? No, not yet. Okay. Good, that's right. For the whiteboard.
Okay, so what do you want? So, y-intercept. That is what you want to keep y. So what did you do that? So the same thing as y. Okay? So then you go y equals, and then negative 1 over 0 plus 1. So you just plug in 0 for, so that you can end up solving for y, you're plugging in 0 for x. Do you finish this one? So it's negative 1 over 1. And usually one is 2x. And then I just change it to negative 1 half. So that's where you have to multiply this to get by x plus 1 and which you and other fractions. Could I have choice? So negative 1 and now. So if you and I don't think something. Can you multiply negative 2 here? Negative 2 times x is negative 2x, but then negative 2 times 1 is negative 2.
Oh.
And then combine the other terms. Okay, so this basically is okay? And so when you're finding the y-intercept, just keep in y. So you write this as y equals negative 1 over 0 plus 1. And then minus 2. And then you're just going to simplify. And then you're just going to simplify. Okay, so y is negative 3. And so that intercept is actually doing 1, 0. Yeah, okay, good. And then
All right, I'm going to go ahead and start going through this, but it looks like some of you that did it. Yep, good. Okay. All right, so finding the y-intercept, remember that this equation, we can think of this as y, okay? And so for finding the y-intercept, we want to keep y, but we plug in 0 for x. And so I'd have y equals negative 1 over 0 plus 1 minus 2. Okay, and so I end up getting y equals negative 1 over 1 minus 2. And negative 1 over 1 is just negative 1. So y equals negative 1 minus 2, which means that y equals negative 3. So as an ordered pair for my y-intercept, it is 0, comma, -3. So 0 on the x and -3 on the y. That is my y-intercept down there. Okay, for your x-intercept, it's the same idea, except for we plug in a 0 for y and we're solving for x. So this time I have 0 equals -1 over x plus 1 minus 2. Okay, we want to get rid of the fraction. We don't want x in the denominator. So this goes back to what we've been doing this whole unit, and that is finding what our LCD is and our extraneous solutions. So with our extraneous solutions, what can x not end up equaling? Good, which makes sense. There is an asymptote there at -1, right? Okay, and then the LCD is going to be good. And so I multiply every single term by x plus 1. 0 times anything is 0, so I have 0 equals. Here these cancel out and I have -1. And then we distribute the -2 through and I get -2x minus 2. We then will combine our like terms. So I have 0 equals -3 minus 2x. To solve then, I will add 3 to both sides. So we get 3 equals -2x, and we divide by -2 to both sides. And so x equals, I would change that to a decimal or a mixed number. And so what is 3 over -2? Good, -1/2 or -1.5. And so as an ordered pair, that is going to be -1.5, comma, 0. And so on the x-axis, I go left -1.5 and 0. Wait, I did not write that in the right spot.
Wow, that makes one.
Everybody makes mistakes.
Yeah, I know. I can't be perfect all the time. Okay. And so that should help you with what your graph looks like. Do you see now which quadrants they're going to be in?
Yeah.
Okay, so that's obviously a song. Is that right?
Oh, yeah.
Okay, so I did not know that. Okay. Yeah. All right. So normally our graphs were in quadrants 1 and 3, but now it's in quadrants 2 and 4, which makes sense with our negative up here and how they would be reflected over the asymptote. Okay? So domain. Can you guys state what the domain is? Taking a vote, how many of you prefer interval notation?
Which one's that?
The one where you do all the parentheses and stuff. Okay. So we know the domain is going to be all reals except what? Good, except x cannot equal -1 because -1 is where the graphs will not cross or touch that line. Okay, for your range, it's going to be all reals except what? Good, y cannot equal -2. Reading the graph from left to right, this one keeps going what? Is it increasing or decreasing as you read it from left to right?
Decreasing.
Starting here, this one's going to be increasing. And then you have to flip right here and it still is increasing. So is it ever decreasing? No. So you can put none or no solution. All right. Now this one is slightly different in that there's not very many places where it's above 0. Okay? Oh no, it says where it's less than 0. Just kidding. Okay, so where do we see, working from left to right, where is it less than 0?
-2.
Starting from left to right, it's below 0, starting at,
Negative infinity.
good, negative infinity, all the way to, and what was this point?
1.5.
Negative 1.5. And so at negative 1.5, I'm going to use a parenthesis or bracket.
Parentheses.
Good. Okay, because that's when it's changing, right? And then the union, and then where am I going to start it again? Where? You're going to start it at -1. Because remember, it's going to get close to -1, but not touch -1. So that's going to be -1 all the way to what? Positive infinity. Good. questions so far? Okay. This next part, and you have homework questions that are like this, I feel is kind of easy. So with all these questions, when you have x in the denominator, you do have a vertical asymptote and you do have a horizontal asymptote for each of them. Okay? So we're going to write VA and we're going to write HA. Now, sometimes for me, it's easier to visually see it than to just think about it and know what to do. So this means we're going to end up shifting the x where? Left 5. Okay? 1, 2, 3, 4, 5. And so that is a what? Is that a vertical or a horizontal asymptote?
Vertical.
Vertical asymptote. So that's going to be at the value of x equals -5. Okay? Now, is there anything being added or subtracted at the end? No. So that means it's going to be at 0. Okay? And that is our horizontal asymptote at 0. So how would I write that equation?
Y
Y
equals 0.
equals 0.
Good. Okay?
Oh,
Because there's nothing being added or subtracted. And so if nothing is there, it's at 0. And that's the same with here. Like if the bottom just has an x, it's at 0.
That's all I have to do.
No, pretty nice, huh? Okay, so can you guys go ahead? I'm just going to give you like 30 seconds or less to write what your vertical asymptotes are and your horizontal over here.
Oh, I was thinking.
Okay, so let's see here. Jordan, did you get a vertical asymptote?
Yes.
What is it?
7.
Good. But we're going to write that
X
as
equals 7.
very good. X equals 7, because if it's -7, it's actually shifting right. Okay, and our horizontal asymptote, Haley, did you get that one? Good. But we'd write that specifically as good. Y equals 4 is correct. All right, any questions there? Okay, we're going to